Okay, last lecture, we stopped at example 5. We deal with this car. And there's a typo error on my slides. All right, take note on that. Okay, today, you look at another example. Rigid body. So there's a motorbike that's given so and so, and you look at the diagram, you already know this is chapter 6 question with the point center of mass G there. We have two center of mass. If you read the question, motorbike have one mass 125 that at center of mass G1. Rider have 75 kilogram center mass G2. Right? You will see this one in your coming test 2 and also your final exam. You have two center of mass. Right. Then determine the minimum coefficient static friction between the wheel and pavement in order the rider to do wheelie, which is the one that you see on the diagram where there's a lift off of the front wheel. What acceleration is necessary to do this one? You need to calculate the A for the motor acceleration. Ignore the mass of the wheel and assume that the front wheel is free to roll. So means there's no contact, there is a contact, but it's free to roll, means no friction for the first one, okay? So how do you draw free body diagram? What do you draw? Free body diagram. Okay, so first one, what do you do? What force you put in first? Weight. Again, weight is on center of mass. Second one, rider weight. Then what else? Why friction force first? Okay. How do you find the friction? What's the equation for friction? Mu. Okay. Where is the n? You don't have? Means the bug is flying on the air. So where is the n? Okay. So one is at where? Where's the location? B and A. Yes. Touch the floor. Again, do weight first, then contact surface. Don't go on and don't go and do other things. You might confuse yourself and you might forget this one. Okay. The friction force pointing this way, why? What? Pointing to the right? Huh? Yes, because of the motion of the wheel. You rotate like this so that motor will move to the right, right? So you will opposite direction, so your friction is to the right. Okay. Then, just take note, NA is nearly 0 when you do free wheel, right? What else is missing? Is there anything missing here? Okay. So, you have free body diagram. Another one is called what? Kinetic diagram. So if the question didn't mention anything, you still need to draw kinetic diagram. If the question just mentioned, construct free body diagram for your calculation, all parameter must be clearly labeled. Although kinetic was not mentioned, and it's chapter 6 question, you should also show kinetic diagram. Okay. So you copy the same thing, cannot overlap. It must be separate diagram. Okay. So what else First, you put first in your kinetic diagram. Huh? MA at where? At where? Location where? How many G you have? Okay. Okay. You have two, you have two objects, MA1, MA2, both have MA. Okay. So for chapter 6, your kinetic diagram, you convert acceleration multiplied by mass become forces. The purpose is that you want to build the relation between the moment of free body diagram compared to kinetic diagram. Then point B, focus on point B rather than point A, because point A later will leave off. So there's no point you refer to a moving or changing point. So put on point B, and then equation of motion, you should be able to find. On the left is all the force you're referring to free body diagram. On the right, you refer to kinetic diagram. Okay, what is the value for AGY in this case? What is the acceleration for G for Y direction? 0, because the motor is not flying from the ground. Okay. So, and then one moment equation. Okay, so these are the three equations you cannot miss when you do chapter 6 question. All right, so the rest is just substitution. Okay, so in this case, because we know that the two objects are moving in the same G, what we do, we group the two objects into one. So we M1 plus M2 because both are on the same, we call one body. So you combine. Of course, you can break, but why you break? Because you can break into another equation like MAGA plus M2AG. You still have the same AG, you still factor them become one. Make sense? Okay. So Y negative FB? Y negative? Y negative? Yeah, but your free body diagram, where you point? Where is your positive direction? Right, but Y negative there? Y negative? Mistake, it's my typo error. Okay. Take note, I think I'm not sure whether this one come in your assignment or not. I'm not sure. So if this question in your assignment you get negative, and your assignment carry a lot of marks, if you give me wrong answer, you don't have full mark for your assignment. Okay. Don't simply copy the answer from my slides. Check before you write in your assessment. So same. You should give NA and you write 0. Why? Initially, what is your value of your NA? Is there any NA before you leave off? So you cannot take out the NA. because initial state already touched the ground, unless it tell you initially already lift off. You try to think how we reverse the question in exam. If I reverse the case, rider was having a free wheel motion. At what speed? This case is two-wheel ground, then lift off. What is the case? What if the question I reverse? One wheel and a two-wheel. What deceleration I need to do so that my vehicle drop, my front wheel drop? Try to think, how do you solve that question? Okay, try to think. Don't don't assume I will come up with a question like your tutorial, like on my slides. You have seen how I ask question in your test one, so you know my style. So don't assume I will give you the same question. Okay, so you do the same. I only need to highlight how to calculate moment of B. Moment of B here. Sorry, moment of B here. So you only see three forces. Anti-clockwise by default is positive. So you have this one, negative, negative, positive. But this one you don't have. So you have negative, negative. By default, anti-clockwise. Positive. You should write where is the positive value for your rotation, for your moment. Okay. So yeah. The rest is quite straightforward. Left hand side referring to kinetic diagram. You stop at B. This one you have two, both clockwise, so you get positive. Negative, negative, right? Okay. So here you solve the simultaneous equation. Okay, you'll get the answer. Okay, so once you have this one, you have the A and B, FB. Your FB is this equation. So when you do equation, don't go and straight away substitute mu n in your equation. Find the complete friction first, because you don't know what is this value. Some of you like to substitute this one inside here. Then you suddenly you will give yourself a wrong direction in solving. Why? Let me explain. So if you substitute there, you straight away you find a mu. Correct? This question okay. This question, it asks you to find the friction, right? Okay. Later, I'm not sure whether in this chapter or next chapter, you are given mu s and mu k. You need to decide which value to use. Okay. This one you can substitute in this case, but I would recommend you find the friction force as the one first, then only you look at the mu. Okay. Substitute. Okay. So here you find the mu minimum is 0.9 if you substitute here. Right? Okay. So later in one example, I'm not sure whether in chapter 6 or chapter 7, you need to decide what value of mu you need to use. Okay. you know that friction coefficient of friction, you have static and kinetics. So you need to decide whether this motor or this vehicle was slipping or non-slipping case. You need to decide that one. Okay, example 7. Example 7, you have a system where it's rotating 2 arms and a rod here. So basically it's a bar case. But this one, even before you read the question, you should able to predict the motion. You're given omega with its angular velocity. So if this one moves this one, so this one will move this way. So this point B will move in a circular motion, D will circular motion. So circular motion, you should use tangent and motion, tangent and normal. And there's an equation for tangent motion, tangent normal acceleration. Okay. You should convert. You should use alpha and omega to find your acceleration or velocity component. So this one, 100 kilogram beam BD supported by 2 rod having ignore the mass. So ignore the mass. So by reading this statement, you know that your focus is on beam BD or object BD. Determine the force developed in each rod if at the instant degree 30 degree omega 6 radian. What is the force in each rod at the instant of 30? So you need to find forces here, forces here. It's back to your statics setting. But here is moving. So you break it one by one. So here you have 30. How you draw your free body diagram? How you draw a free body diagram? What is your force? The question asks you the force developed in each rod for the instance. So you have one rod here, one rod here. You have A, you have D. You want to find forces. What are the forces at A? How you draw forces at A? A is what? Pin. So how you draw forces at pin? What is the force at pin look like? Okay. Anything lah, as long as it look like this. How you draw pin force? As long as you have X and Y axis. You can even draw like this. Or doesn't matter. Okay. So if you want to be more concise, you try to imagine your pin A. Your pin A, what do you feel? You just think, what do you feel if you're A? What happened to your hand if you are holding rod AB? What do you feel? You feel the force pressing in or going out? In this case, you are like standing like this one. right? You are standing, if you are A, you are standing like this, right? So the rod AB, you are holding like that, right? So AB is connecting to BD with 100 kilogram. So what do you feel? You feel the force going in or going out? Going out. So then the object will swing to left hand side. You're pushing, you are tends to move to left, right? Correct. Correct or not? If you swing this one, you are A. You imagine you are the pin A. The pin A. So pin A moving, BD moving. So you are tends to pull to left, right? If you from your side, you pull to the right line. Okay. So I tends to move to the right. So there's a force to the right. This is pin A. So this is your AY, AX. This is from the pin. So you connect this one to the pin. It must become with coupled. Means you must eliminate the force. So you eliminate this one. Go up lah. This one. Or you eliminate this one. Go to the left lah. Sorry. AX, AY. Okay. Same with the C. C also feel the same. Okay. Yeah, same. So if you really don't understand, you just imagine you are that object, then what do you feel? Right? So if really cannot, you just simply put standard one up and down, up and to the right. If you really don't know, then later you get negative sign. If it is opposite of that direction, you get negative for that. Means the one that you draw on the free body diagram is wrong direction. Understand? Yeah. So this is how you solve problems. Okay, then here to here also need to have coupled system. Okay. And then you know from rod system how the force transferred along the axis. Okay, so B, how B transferred? 45 degree, not 45. In this case, it's 30 degree. Okay. All right, so the rest you read. You'll get for rod AB, you have acceleration in tangent direction, normal direction. Normal is pointing to the center of the curve. So it's along the body of AB. You have alpha, you have omega, the length is there. It makes sense, all right? Then normal acceleration, omega square r. You substitute, omega is given, r is given. So BD, again, G is given. When you draw free body diagram, all the weight must go through center of mass. W will go first. All right. Then the forces pulling at both ends will follow the link. In this case, will be 30 degree. Same with here, 30 degree. Okay. So, Tina, any questions so far? Okay. So, then kinetic diagram. How you draw a kinetic diagram? Huh? Huh? MA at where? Where usually your A will be. You see, you forget already. I still write on the whiteboard here. Yeah. You focus on G. Chapter 6, you always focus on center of mass. So where's center of mass? Center lah. Then, in this case, your center of gravity also rotate collinear motion. Makes sense. So don't be tricked by nothing here. Your B move in collinear, D move in collinear, but this is one body, so your center of mass also move in collinear motion. Collinear motion, you have tangent and normal direction, so same. AG and AT, what is the direction? 30 degree from the center. Same. Yeah, so this is a tricky place. Huh? Okay, so you have three unknown, TB, TD, AG. Okay. AN you already find. AN you're given omega just now. Okay. So you use equation of motion. What is equation of motion? F equal to ma. So we break into two. In this case, because the body move in the collinear motion, that's why you no longer see x and y. You see normal and tangent direction. Makes sense. So don't like confuse like, hey, when should I use x? When should I use? As long as you look at the motion, you know already. If the motion, if the object move in a straight line on the surface, then you use x and y. If the object move in the collinear motion, very high chances you need to use normal and tangent. Okay, so in this case, I give myself positive direction. In this case, normal along the rod. Tangent is at tangent of the curve. In this case, I focus on center of mass, G. Okay, so you group all and then you do one more moment at G. Okay, right. Any question for normal tangent to find the force? Can do. Okay. So how to find moment of G for free body diagram? Close this one. What is the equation you have for free body diagram? Anti-clockwise positive. Mg equal sum of mk. What is on the left hand side? How do you write? Left hand side, you look at which diagram? Free body diagram. At what point? You close G. How many forces you have? Huh? Three forces. You want to calculate moment. Moment you close it here, you have two forces. So first forces is where? So how do you find moment? What's the distance you use? Times what? Yeah. Which one? Okay. So your answer, first one is what? PV cos 30 times 0.4 positive negative. Positive negative. Why positive? You are saying force or moment? You say pointing that way. Is that moment or force? You are dealing with moment now. Okay, so positive is what? Anti-clockwise ma. So this one is clockwise ma. So negative ah. Is that all? What else? Positive, negative. Huh? Positive, negative. Zero. Equal. Kinetic. Kinetic, you look at this one, right? At what point? G. What are the forces you have? Huh? What is this? MA is what? Force. I'm asking you moment. You put it here. So, huh? So what's the answer? Zero, because the D is zero. Even you flip this one, like we flip this one to x-axis, the D is still zero. Same with this one. Even if there's no force there. That's why I keep mentioning, be careful on the force you put. All right? Don't like draw off, then you will trick yourself. Oh, there's a force, there's a moment there. Okay, so zero, makes sense. Yeah. So I'll give you all the answer. Okay, makes sense, Zero. Then you solve and you get answer. Okay. Right. So next we look at rotation as a fixed axis. Okay, rotation as fixed axis. So what is different from the previous section is that now you're looking at one pinpoint here, and then there's a G point here. Okay, then this object rotate clockwise. Sorry, anti-clockwise. And then there's an additional force there. Okay. In this case, if a rotation means your object is moving in a collinear motion. So you're only seeing tangent normal direction. And then recall link alpha, omega for tangent direction acceleration, tangent direction acceleration. You can find this one with omega and alpha. Okay. So again, tangent is alpha r, normal is what? Omega square r. So by now you should already you know already, right? Okay, the rest you go and read the slides, change the free body diagram and kinetic diagram, still same. At the end of the purpose of doing free body diagram and kinetic diagram is to use the three equation. F equal to ma, break into x and y or normal tangent, you get two equation there, and one more moment equation. Moment for free body diagram equal to moment to kinetic diagram. Same. And focus will be on center of mass, G. Now you have one more O here. Okay, previously you don't have this one, but now you have fixed rotation at a certain angle, right? So I'll just go very fast. I don't, okay, now you learn one more equation. If that object was fixed to one point, your moment equation you can calculate with Ig alpha. Okay, how you find Ig? Form chart, form table. Okay, you have two. If you use IO equal to IG plus MD square. This is from center of gravity. If you have a fixed point, then I give you one more equation. You see the equation? The equation change, at the end. This equation at the point O, it will change form already. If you find all the moment at O, you see the equation, you have mg square plus ig alpha. You see the form different, If you look at G only, you have I alpha, Ig alpha, but you have O, you need to modify a little bit the equation. You need to consider the mass at the gravity, at the center of mass, mRg plus Ig. You need to add this one, compared to gravitational point. And the IO equal to Ig md square. Need to be careful what question asks you. The previous section, we always focus on G. But if the question flip a little bit, it asks you, you calculate moment at that particular point. In this case, O. Means you shift your G point reference to the another reference point G, O. Then you modify your equation. You need to consider from Ig change to IO. For example, your moment equation, you need to add mr squared from the G point. Same with IO. You need to calculate the IO equal to Ig plus md squared. See a difference, Try to differentiate what is different now. Okay. Yeah, just now the same question. The example, we are looking at G, calculation G. If I use the same question, I do not ask you from G, I ask you from one center point here on the ceiling, I put an O there. Or I put B as your reference. Then what you do? You need to modify the G equation into here. You add mRg squared plus Ig, and then you need to use IO equal to Ig plus md squared. What is D? D is the distance from the reference point to the center of gravity. Okay. Okay. The last two you familiar. Okay, MA, normal tangent because this one rotate. But the moment here change already. Moment here referring to rotating point. Here. Previous example, we look at G. The whole body rotate. But now it pinned to one body, for example. For example, this one was pinned to here. This one rotate, right? Find the moment of this body. This one cannot, because this one keep changing, cannot. What happened? You have a one fixed point. Then you need to modify your equation based on that single point. Okay. So let's look at example 8. Example 8, you have pin O, or in the question you see O and G, means you can no longer use the previous one. You need to use O equation, MO and IO equation. That is the difference. The rest is the same. Okay. Example 8, you have this that imbalance. How you know imbalance? Balance this, your G will be at the O here. Imbalance means there is a shift of mass at a certain point. Okay, so it's like if you drive, you need to do balancing of a wheel. if your wheel do not balance, means the gravitational g distance will shift outwards. Then the mechanics will fill in the small mass inside the tires, so that the center of gravity will shift back to the center of your wheel. So when you do balancing, you see the mechanics insert some steel plate on the rim there. So that is the reason why they do balancing. Okay. So if the unbalanced mass was given, radius of gyration k. So when you give radius of gyration, you need to use gyration equation. If it release from rest, so when this release from rest, what is the motion that you can predict? It rotate. How it rotate? Clockwise or anti-clockwise? Why clockwise? Okay. Yes. So this one will rotate clockwise because center of gravity is here. So it release from rest, so it will this G will point down, right? G, the central of mass, all the mass will go through this point. So the mass will pull from here. This one will lock, so it will rotate clockwise. Yeah, logic prediction. Okay, free body diagram. Put in O, put in G, put in the W, mg. And then pin again. Pin. If you really don't know, you imagine you're a pin, what do you feel in this case? You sit there, and then the disc is on your body. So you're actually feeling the force is pressing your body, right? Correct? You imagine you are the O. So what do you feel? You feel something pressing, let's say you are your head, right? And then the disc is rotate this way. So it rotate this way, your tends to like, so most of the year your force is like that, right? So you have two forces. One is here, one is go down. So you do the coupling to the disc. So this will be flip. You flip up and flip here. Makes sense. But if you if you really don't know, then you just use the default one. Go up and go to the left. All right. XY. But at the end you get negative, means the one that you predict in your free body diagram is wrong. Makes sense, huh? Okay. So weight go down. We have this one. Okay. Right. So, and then this one rotates circular. So tangent go down, normal go inside. Okay. So kinetic diagram. What is expected? What should be in your kinetic diagram? O and G. MA at where? Where? G or O? G, huh? YO don't have acceleration? Fixed what? It was fixed what? So no acceleration, no velocity. Then only G is moving. What is the direction of acceleration at G? Normal and tangent. Okay, you have two, because circular. So normal and tangent. So once you have normal tangent, you actually can find the resultant. Although this do not go into that. But once you have normal tangent direction, you can find the angle of resultant and also the resultant vector. Yeah. So yeah. Yeah. So MA go down. Tangent is alpha R. And then there is moment, second moment inertia, IG alpha, that create the moment. Okay. Yeah. So there are two things you need to consider now is that there is a moment inertia take into place beside the acceleration. Yeah, so you need to add one more with this Ig alpha and give you the moment and the force as a result of your acceleration. Okay, angular velocity here is 0, right? So you only have ma. Okay, then what else? The purpose of giving you the gyration, because the question want you to calculate Ig equal to mk squared. You use gyration to find the Ig. In this case, even you use the chart, chart will also give you mr squared. Okay, substitute the value, you get the Ig. Once you find Ig, you can find the moment alpha. You can calculate. So again, modify a little bit. Mg equal to gravity equal to Ig alpha. F equal to ma. This one you know, and then you change the acceleration in normal tangent into omega and alpha term. Okay, the rest is substitute. Plus, you add G, you only see, okay, here, free body diagram. This one is free body diagram. So you add G, you close G, you only see this and this. But this do not create moment because it's perpendicular to the distance. So you only have one. And this one, clockwise. Why positive? Because in my case, I follow the rotation motion to be positive. Although by default it's anti-clockwise. But to make my answer become positive, I follow the acceleration direction or the object rotation direction. That's why I put positive here. Yeah. Ig you define alpha. So Fn, normal direction. So Fn, you have O. The rest don't have. So Ma here, normal, you don't move anything. So 0 or omega 0. So same with T negative. Why T negative? Why T negative? What is my positive direction? For tangent. Go down. Why go down positive? I rotate clockwise. Where's my tangent positive? Go down. So when you do your F equal to ma equation, tangent go down positive. This OT point up, it give you negative. So just be careful if you have rotation body. Once you fix, you better draw the positive direction on your diagram. Then you can see where is positive, where negative. Okay, important to have this N and T diagram on your free body diagram. Okay, plus W, this is on the free body diagram side. Then M, this one alpha R. You substitute, you can compare this one and this one. This one's okay, this one and this one. You're able to solve simultaneous equation. Then here only you find alpha OT. There's one more missing. Don't have this one yet, right? So this one 0, in this case 0. So you can also find using moment. This is already find all the answer already. But one more suggestion. You can find the moment at O, right? Just application. This is a second set of the solution. So MO means you look at O and sorry, this is free body diagram. Okay, no, free body diagram here, kinetic here. So MO will equal to MO kinetic diagram. So here, you put here, you only see W, correct? W, 0.15. Right inside kinetic, you look at here, O, we have one moment here, one moment here. Okay? Make sense, huh? Substitute, you get the first equation. Second one, you use I. Once you need to use O, remember you need to use Ig plus Md squared. Okay? Ig plus Md squared or R. Okay? So you substitute the value. Okay, substitute the value. What else? Then you use the F equal to MA to solve the equation. Okay, so this is how you solve. Okay, example 9. See, the 9. Okay, we continue next lecture.